Good morning, students. Today everybody is looking very smart. In our last module, we discussed about the concept of work. I think everybody has understood the differences in meaning of the concept work in our daily usage and in physics. In physics, the term work has got a very clear definition, isn't it? Yes. Today, we will understand the concept more in detail, and also we will learn how to calculate the value of work done in different situations.
Students, first of all, we'll see what is the meaning of this term work. So see students, there are some words like fan which have two meanings. See, this is a fan, or you may be a fan of Katrina Kaif, you may be fan of any other superstar, film star, you may be fan of any other sports person, right? Any politician. So fan is a word which has multiple meanings, students. Similarly, work also has multiple meanings. One is the work which we understand in our day-to-day life, and another is the work which we understand in physics, students, in science. For example, suppose students, tomorrow is your exam and you are studying day and night very hard, right? So students, as per normal definition of work, day-to-day life definition of work, you are doing a lot of work, you are doing a lot of hard work, students, right? So day-to-day life, you are doing, by the meaning of work as it is in day-to-day life, you are doing lots and lots of work, students. But by the definition of physics, by the definition of work as in physics, you are doing no work, students. Very sad, very sad. As a teacher of physics or as a person who knows physics, I will tell, okay, this person is doing no work. He's lazy. He's doing no work. You understand? But as per the definition of work in our day-to-day life, you will say that he's doing a lot of work. So that is what I'm trying to explain you. As this word fan has multiple meanings, this word work also has multiple meanings. That is the most confusing thing about this chapter, right? Students get confused. Don't get confused, students. This word work has different meaning in our day-to-day life, and it has different meaning when we are studying physics. Okay. See, students, in physics, mental labor is not considered work in physics. So you can see in physics, definition of work is different. In physics, any mental work will not be considered to be as work. If you are thinking, if you are in your deep thoughts, maybe that thought is about any subject in maths, physics, history, or whatever. In day-to-day life, it may be considered that you are doing some useful work, but not in physics, students, not in physics. So students, let us see here what is the meaning of work as in physics, according to physics. So let us see this situation to understand work. So the situation is very simple, students. There is ground here, and on the top of ground you can see there is a block kept. There is a person here, and the person is pushing the block ahead by applying force of 10 Newton, students. You understand what is the situation? Now if the person is pushing the block ahead, the block may go ahead. So the block goes ahead by 5 meters. It is given to you. The block goes ahead by 5 meters. So in this case, students, we have to calculate work. See, students, there is very simple formula to calculate work, and it is force into displacement. Force into displacement, students. Now see, what is the value of force, students? That is 10 Newton. And what is the value of displacement here, students? You can clearly see 5. So in this case, we'll say that the work is 50. In this case, we'll say work is 50. It's so simple, students. Or it may also be written as like this: work done by force equals to 50. So the work done by this force, which is being applied by the man, is 50. Work done by force is 50, students. Or we can also write here that work done by man is 50. Right? All these are same things. Work done by force, you can write work done by force is 50, or you can also write work done by man is 50, right? Because man only is applying that force, students. Understand? Now students, let us do this small example here. So once again a block is lying on ground and a person is applying a force on this block in forward direction. Say the value of that force is 20 Newton. Possible, students, right? And say one more person is pushing the block ahead like this by applying force of 30 Newton. Right, students? Possible. So two people are actually applying force on this block. One person is applying force of 20 Newton in forward direction. Another person is also applying force of 30 Newton in forward direction. And due to these two forces, the block moves ahead, say by 2 meters. Possible, students. Now in this case we have two forces, students, two forces. So in this case, how will we find work, students? So for this force, say this force is called F1, students. So we'll say work done by force F1. Work done by force F1 is equals to force into displacement. That's the formula, students. Force into displacement. So the value of this force is 20 and the value of displacement of block is 2. So that is 40. So we'll say work done by this force, is 40, students. Now we want to calculate work for this force, students. So we'll write work done by force F2 is once again given by this formula, force into displacement, students. Force in this case is 30 and the displacement of the block on which this force is acting is 2, students. So the work done is 60. You understand, students? So it's very simple. So see, if only one force is acting on the block, there's absolutely no confusion and it's a very simple case. By using this formula, you can calculate work done by that force. If multiple forces are acting like this, in this case you can see two forces are acting. So if you want to calculate work done by this force, you take this force and the displacement If you want to calculate work done by this force, then you take this force and the displacement. Right, students? You understand? So this was our first point regarding work in physics, students. Now let us see work in more detail. So let us see point number 2 related to work, students. Slowly we'll see many points so that you clearly understand what is work in physics. So okay, this point number 2. So students, once again there is a block lying on ground, students, and two people are applying force on it once again. First person is applying force on this block in this direction. Say the force is 50 Newton. Possible, students, and this force is called F1. So some person is pushing the block in forward direction. Now there is another person who is applying the force, applying a force on this block in this direction, and this force is actually 10 Newton, students. Possible, students. So you tell me now in which direction this block should go. Tell me. See, this force is larger and this force is smaller. So you understand, students, this block will go in this direction. Suppose this block goes in this direction by 4 meters. Okay, students. Now we have to calculate work done by this force and the work done by this force, students. So first of all, let me calculate work done by this force, students. So work done by force F1 will be written as force into displacement, students. That's the formula. So the force here is 50 and you can see displacement here is 4, students. So the work done here is 200, right? Okay, now let us calculate work done by this force, students. So once again we'll write work done by F2. So once again we'll use formula force into displacement, right, students? No, students, there is a small catch here. In this case, the formula will be minus force into displacement. I'll tell you why. Let us first of all calculate the value of work. So the force here is 10 and displacement here is 4. Right, students? So the answer is minus 40. You understand? So students, the concept here is, see, when we are talking about this force, then the direction of force and the direction of displacement, they are same. You can see, students, the direction of force and the direction of displacement is same. So in this case, direction of force and displacement is same, students. But in this case, students, in the case of this force, you can see, what can you see, students? What can you see? See, the force is acting in this direction, but the displacement is in the opposite direction, students. So direction of force and displacement is opposite. So see, students, when force and displacement are in same direction, then work is positive in sign. Work is positive in sign, as you can see here, 200. But when direction of force and displacement is opposite, students, then work is negative. Work is negative. See here, the work has come negative, students, right? So that's why I was using negative sign here, students. So whenever you see that force and displacement are in same direction, you should not use negative sign here. But if you see that force and displacement are in opposite direction, students, you should use negative sign here, students. You understand? That is very important, students. I hope you understand the point. This point may also be written in slightly advanced manner, students. See, in this case, students, force and displacement, they are in same direction. So sometimes people also say here that angle between force and angle between force and displacement is 0. Angle between force and displacement is 0. So if force and displacement are in same direction, we say that angle between force and displacement is 0. But when force and displacement are in opposite direction, we say that angle between force and displacement is 180 degrees, students. 180 degrees. You understand? So sometimes you will write, you will find written in books that if angle between force and displacement is 0, work done is positive. But if angle between force and displacement is 180, work is negative, students, and we use this formula. You get the point? Fine, students. So we have seen the second point related to work. Now let us move to the third point, students. So for that, let us look at this situation. So you can see this is ground, students. Look carefully. This is wall here. At the corner there is a block, right? Now a person is applying force like this on this block, students. He's trying to push the block ahead by applying some force of 10 Newton, right, students? Right. So what is the displacement of this block, students? What is the displacement of this block? What do you think, students? Clearly it is going to be 0. Clearly there is wall here, students. There is wall here. So no matter how much force you apply, the block is not going to move ahead because of the wall, students. So obviously the displacement of this block is going to be 0, students. Fine. But anyway, we are actually more interested in work. So let us find out work, students. Why are we wasting our time on displacement, right? Let us find out work. So the formula for work is force into displacement, students. So see, force is 10, but displacement here, as we discussed, is 0. So the work here is 0. So the work here is 0, students. So this person here is doing no work. This person here is lazy. According to physics, he is doing no work, students. So students, see, in normal life, you may think here that work is being done because the person is pushing the block. But as for physics, the work is given by this formula. So if displacement is 0, work is also 0. So students, we can actually write down, this is a very important point, that in physics, work is said to be 0. Work is said to be 0 if displacement is 0. If displacement is 0. No matter how much force is applied. How much force is applied. No matter how much force is applied. You understand? Let me give you some more examples. Look at this photograph, students. So this is a real life photograph. You can see there is a person here who is holding a big rock, very heavy rock in his hands, students. So you have to calculate what is the work done by man here. So the work done here will be, students, force into displacement. So let us not talk about force first, let us talk about displacement first. So the man is only holding the block, he's not moving it. Please note, he's not moving it. So what is the displacement? What is the displacement of this block? Obviously 0, because the block is not moving, block is not moving, block is not moving. Right, students? So the displacement is clearly 0. So no matter what is the value of force, work done by man will be 0. Isn't it, students? You understand? So as per physics, the work done by this man is 0. But students, see, as per normal day-to-day life, you may think he is doing a lot of work. You can see, look at his face, students. He's getting so tired. So, you may think that he's doing a lot of work, but as per physics, there is no work here, students. You understand why? Let me give you one more example. So look here, students, in this photograph, you can see there's a small child and there's a big rock. He's pushing the rock here, students, by applying some force here. Right? He's applying some force here, you can see. He's trying to push the rock. He's trying to push the rock. But is the rock going to move? Not at all, students. So what will be the displacement of this rock? 0, students. So what is the work done by this little champ? What is the work done by him, students? So you understand, right? That work done by him will be force into displacement, but as the displacement is 0, work done will also be 0, students. So I'm trying to emphasize a very important point here, students, that in physics, work done is said to be 0 if displacement is 0. No matter how much force is applied. See, the formula of work is force into displacement. Simple. If displacement is 0, work will also be 0 in physics, right? So now let us move to the next point regarding work. So the fourth point regarding work here, students. So once again, suppose a block is there on ground, students, and due to whatever reason this block is moving ahead. Say this block moves ahead by 2 meters. Okay, maybe somewhere somebody is pushing it ahead or whatever, but it is moving ahead by 2 meters, students. Now see, you can understand that a gravitational force will act on this block. A gravitational force will act on this block in downward direction, students. In downward direction. In downward direction, students. We have studied about this force in previous chapters, students. I'm sure you must be able to recall it. So can you tell me how much of this force is acting here? If say the mass of this object is 10 kg, can you tell me, students, how much is this gravitational force? I'm sure, students, you are able to recall and you must be shouting loud that how much is that force. So that will be equals to m into g, students. M is 10 here and g is 9.8. So the force will come out to be 98 Newton, right, students? So this much of gravitational force is acting on this body, students. Now the question here is that we have to find work done by this gravitational force. We have to find work done by this gravitational force here. So how are we going to find it, students? See, students, it's very simple. It's simply 0. It's simply 0. It's simply 0. Why, students? See, the point here is that look at the force and look at the direction of displacement. So students, they are perpendicular. They are perpendicular. They are perpendicular. See, look at the direction of force and look at the direction of displacement. Don't you find them perpendicular? Don't you find them perpendicular? So the rule is that if force and displacement are perpendicular, work is said to be 0. So let me write this down, students. If force and displacement are perpendicular, work is said to be 0. Work is said to be 0 as per physics, students. Right? Very simple, students. If force and displacement are perpendicular, work will be 0, students. Force may not be 0, displacement may not be 0, but they are perpendicular, so work done is 0, students, as you can see here. So see, force is not 0, displacement is also not 0, but still work done is 0 because they were perpendicular, students. Let me give you some more examples. So let us see at this example, students. So you can see a person is carrying this substance on the top of his head, okay, and he's walking forward. Okay, so see, uh, let us focus on these branches of tree, thin branches of tree, students, or this wood we can say. So as a person is moving ahead, displacement of this wood is in forward direction, students. You can clearly understand, right? So if the person is moving ahead, along with him this object is also moving ahead. So the displacement of this object is in forward direction, right, students? Now this person is applying force on this these stems in upward direction, students, right? To hold it, to hold them. You understand? So the person is applying force on these stem in upward direction, students. So what is the work done by man? In that case, what is the work done by man, students? What do you think? Zero, simply because displacement and force, they are perpendicular, because they are force and displacement, they are perpendicular, students. You understand? So students, don't be confused. You may think that, okay, no, this person is doing a lot of work, he's carrying lot of weight on his head, he will get so tired, so how come he's not doing work? He's doing work, right? You might be thinking that. But students, I told you that as word fan has two meanings, similarly this word work has two meanings. That is the point of confusion. That is what students don't try to understand, that this work has two meanings. In our daily life this work is a different thing, and in physics it is a different thing, students. Don't mix them, students. When we talk about work in our daily life, it's a totally different thing, and when we are talking about work in physics, it's a different thing, students. It's a different thing. So as per the definition in daily life, this person is doing a lot of work and that's why he will be paid for it. But as per physics, this person is doing no work because force and displacement are perpendicular, students. You understand? You understand, right, students? But students, don't try to teach this meaning of work to this guy. If you go and tell him that guy, hey person, listen, you're not doing any work because your force is perpendicular to the displacement, so you're not doing work, I'm not going to pay you. If you tell this to him, he will slap you. Okay, so don't try to teach such physics to him. So anyway, jokes apart, students, in daily life, as per the definition of work, he's doing work, but we are here studying science, physics. So as per the definition of physics or science, there's no work here. Work is zero. Well, next point number 4 regarding work, students. See, if you are actually studying, there is no force involved here as such, and there is no displacement involved here as such, right? When you are just studying, you are just doing some mental work, students, right? But as such, there is no force involved in your action and no displacement involved in your action. So in this case, work done will simply be zero. Sometimes work is denoted by just W. Okay, so in this case, work done will be zero, students. So we can write down, if no force and displacement are involved in a situation, work is zero. So if we have a situation in which there is no force, no displacement, work done is simply zero. Very simple. So students, we have seen a lot about work by now. So it is a good time to have a summary of what we have seen till now. Okay, students. So let us see. So this was a point number 1 which we studied, students, that if a force is acting on the block and say the displacement of block is S, then what is the work done, students? The work done in this case is simply force into displacement, right, students? Very simple. That was the first point which we actually saw. The next point which we saw, students, was like this, that if force is acting in this direction but displacement is in opposite direction, students, displacement is in opposite direction. In this case, how do we calculate work, students? I told you, in this case, work is minus force into displacement, right? That is the formula which we use. Now this was the next situation, students, which we saw. Suppose we are applying force on an object, but as you can see in this case displacement will be 0. So what will the value of work, students? In this case value of work will be 0. Look at this case, students. We have seen this also. Suppose we are talking about this force which is perpendicular to the displacement, So again in this case work done is, students, how much? 0, students, 0. And this is the last point which we have seen, students. If in any situation there is no force and no displacement involved, clearly work done in this case will be 0. Fine, students. So just keep in mind these cases. Work equals to force into displacement minus force into displacement when force and displacement are in opposite direction. And in these three cases, work done is 0. So students, time for an interesting question. In which of the following activities work is being done? So the question is simple. Lot of activities are being shown here. You have to just tell in which of them work is being done and in which of them work is not being done, means work is 0. Okay. So okay, this is swimming, students. So you can see somebody is swimming. So is there any work being done? As per physics, obviously as per physics you have to tell. What do you think, students? See, students, this lady is applying force. Obviously she is applying force on water, right? She is applying force on water, right, students? And obviously there is displacement here. She is moving, right? She is swimming, students, right? She is swimming. So what do you think, students? Obviously work is being done. Right, students? Very simple. What do you think about this case? Lifting water from well. So you can see a lady is pulling the rope down so that water comes up. So is there any work being done here, students? What do you think? See, there is displacement. The displacement is in upward direction, right? Water will come up. And the lady is applying force, students, in downward direction, right? So what do you think? Definitely work is being done here. Work is being done. Now look at this situation, students. So you can see photosynthesis. Photosynthesis is going on, students, right? Light from sun comes. It is absorbed by plants to make food. You know all this, right? So is there any work being done here, students, as per physics? What do you think, students? What do you think? Tell me. No, students, work here is 0. Why work here is 0? Because there is no force involved here and no displacement involved here, students, right? So if there is no force and no displacement involved, as I told you, work done will be 0, simply. Next question, students. Tell me this. A donkey is carrying load on his back, students, as you can see in the photograph. So the donkey is moving ahead and he's carrying, load like this. So what do you think? Work is being done or not, students? We have already done such example, students. See, as a donkey is moving ahead, this load is also moving ahead. So displacement is in this direction, and this donkey must be applying force on this load in upward direction, right? So donkey is applying force on this load in upward direction. So force and displacement, they are perpendicular. So clearly work done is 0 in this case, students. Understand? Right? Okay. What about this case, students? An engine is moving, students. A train is moving. So what do you think, students? Engine moving train. In this case, work is being done or not? Tell me. So students, you can see this is engine, and then behind it there is train, students. So engine must be applying force on train like this, and that's why train is moving forward. So its displacement is in forward direction. So obviously work is being done, students, right? Now what about this case? So here you can see that grains are being dried. So what do you think? Work is being done or not? See, students, once again there is no force involved here and no displacement. So work done here is 0. Let us talk about this case. Wind moving boat, students. So you can see this beautiful boat. This is moving, due to wind. So what do you think? Work is being done here or not? See, students. See what happens here. Wind blows, and it hits the boat, due to which it applies a force on the boat in forward direction. So force is being applied on the boat by the wind strengths, right? And